Bismillahirrahmanirrahim. Ini depan benar ada yang mau masuk lagi silahkan. Ada? Baik, kita mulai. Assalamualaikum warahmatullahi wabarakatuh. Selamat pagi dan salam sejahtera bagi kita semua. Yang kami hormati Bapak Kepala Departemen, Bapak Latiful Anwar, kemudian Bapak Ibu Dosen Departemen Matematika SMK Universitas Malang, kemudian narasumber terhormat kita, Asosiat Profesor Dr. Siti Rahayu Mohasim dan Muhammad benar, Masya Allah, Alhamdulillah, Muhammad Hasim dengan ekspert di Matematik with Economic Program. Beliau adalah koordinator Postgraduate Studies dari Fakulti Sains Teknologi University Malaysia Sabah, Malaysia. Jika bisa tepuk tangan terlebih dahulu untuk masuk ke ini. Selamat datang dokter di Departemen Matematika Universitas Negeri Malang. Kemudian selamat datang juga kepada seluruh mahasiswa yang berbahagia. Pertama, marilah kita panjatkan puji syukur atas kehadiran Allah SWT karena rahmat, hidayah dan karunia-Nya kita dapat berkumpul pagi ini dalam keadaan sehat walafiat dan tentunya juga bahagia untuk mengikuti kegiatan Best Lecture 2026 dengan mengangkat tema yaitu From Basics to Breakthrough, a Journey in Statistical Modeling. Oke, langsung saja saya ingin memperkenalkan diri. Saya Firda Marifatul Jana, dokter. Di sini saya adalah MC sekaligus moderator yang akan memandu acara pada pagi hari ini. Terdapat beberapa susunan acara pada pagi hari ini. Pertama adalah pembukaan, kemudian inti acaranya yaitu penyampaian materi dari Dr. Kiki, kemudian sesi diskusi dan tanya jawab, foto bersama dan juga penutup. Ini juga di inti acara pada pagi ini. Pada kesempatan ini kita mendapatkan kesempatan yang luar biasa untuk belajar bersama dengan Dr. Siti Rahayu. Beliau akan menyampaikan materi tadi kepada beliau. Waktu dan tempat dipersilakan. Assalamualaikum warahmatullahi wabarakatuh. Introduced by lovely MC now. My name is Lorraine. I'm very glad to see you all. And first and foremost, I would like to say I will get up this evening and then we have learn from, and then I think I know what it is obviously true. So it's my Jamia, sorry, I'm very poor. Right, so actually we work together like used to be, but somehow we got picked up so many times. And then I was also informed that today the audience among the first year undergraduates. Undergraduates, most of them or all of them? All of them. In mathematics education. Mathematics and mathematics. And then we have lectures as well, apart from our dear Paul and Dr. Yama. And then we have another one there. I'm so sorry if I don't see I'm asking the topic. And the one that is sitting next to you. Repeat one of the lectures. Yeah, okay, so 18. Yeah. And let me see. Right. Okay. Let me introduce myself again. This is what actually I didn't. I thought that the guest lecture will be our theme. The session by our theme. I didn't expect that we would use the half hour because they told me that we will be in one group. And then later on, we were informed that it will be based on the program. So what I'm going to present today is my presentations during my guest lecture. I think. So this is my first time in Malang, right? So me by education, my first degree in statistics. If you are familiar with UTM in Malaysia, University of Malaysia, yeah. And then I did my master at UTM, National University of Malaysia. My master in quality improvement in what it's a bit applied.
So not pure statistic on maths. It is more an applied area where most of my classmates were among the engineers from the factories like Sony, right? Uh, the industrial, from the industrial. Right. And then when I joined UNS, because before that I was one of the lecturers under University of Malaysia, National University of Malaysia, Cawangan Sabah. So I have a branch in Sabah before they combined with University of Malaysia as well. When we have University Sabah, when we have University Malaysia Sabah, all the staff under UKM Cawangan and Sabah, we masuk combine with the UKM. So that's what happened. That's what happened. And then I did my PhD in probability and statistics in Sheffield University, United Kingdom. Sheffield. If you are football and soccer fan, then you know Sheffield soccer. Right? Yeah, we have so many clubs. Right. So first, I would like to apologize because this presentation is actually quite long. I have 51 slides. This is actually a presentation for 3 hours. Yeah. So I try to skip any slide so that we can manage to have about 15 minutes. Right? Because it's already, yeah, it was already. Right. So this is the outline of my presentations. We will go briefly on the introductions. Before we go further, maybe you would like to know what's the difference between mathematical modeling and statistical modeling. Actually, I had a debate with one of my professors. I think if you are familiar with Professor Maswani, okay, never mind. You can Google him later. Right? So, is there any difference between mathematical modeling or statistical modeling? So I have my own point, right? Why I think it is different. And then for him, whatever that ended with an equation, it is mathematics. Yeah? So we have two different philosophies, okay, between the mathematical modeling and the statistical modeling. Since that I am the speaker today, so of course I will go for statistical modeling, especially my mind that now is in statistics. But it is open to you whether you want to accept it. There is no pressure on that. And then maybe we can go a bit on the why the statistical foundation matters, because this is the problem nowadays. And we have all these machine learning, the statistical programming background, right? And then the coding, the programming. So the students eager to write coding, right? And then maybe they eager to use any advanced to them statistical software, right? To the extent that we forgot, yeah, the basic concept in statistical modeling, which is the basic statistics, right? And then we will discuss a bit on the statistical foundation for the statistical modeling. I will highlight a few obvious problem hiccups and mistakes done by the researchers, not only by the students. It is also done by the researchers, especially those from non-mathematic background, those from the non-mathematic background. And then we have the statistical thinking versus software. Why with all these advanced statistical modeling, statistical packages, right? Why do we still need statisticians, right? So do not worry, even though we have so many softwares in the market, free and sometimes paid for, right? We still need a good mathematician and statisticians for so many reasons. For so many reasons. So I will highlight a bit on the pitfalls and then the precautions that we need to take in statistical modeling. Is it clear? The outline, I hope. Right. So now, what is the difference? What is the key differences between mathematical modeling and statistical modeling. So I had a brief discussion with one of my colleagues from physics department, right? If you see the first key difference is the theory versus data driven, okay, data driven, right? At the top of the point there, you can see F equal to MA, yeah, the Newton, okay, the Newton theory. So this is the second Newton theory, right? And then the first one, and then the second one, and the third one. So normally in studies, in mathematical modeling, it is actually related to mechanism, theory, yeah? So we have force equal to mass times accelerations. This is a concept, this is a theory about the physics, right? And then, whereas for the statistical modeling, you can see the equations below there. Y equal to delta naught plus delta x1 plus delta x2, and then sometimes we include the error term, right? So the difference between these two, it is very obvious. The first one is a concept. The second one is something to do with estimation. Yeah, estimation. So we have theory, we have data driven. Okay. So for the mathematical modeling, we have the theory, we can run the expression. But for the statistical modeling, we need data. Then we can proceed with the modeling. That's the difference. And then the second one is the deterministic versus probability. So sometimes, not all the time, but most of the time, mathematical modeling is considered as deterministic. So like for just now, the example on cost equal to mass times acceleration, right? So the theory of the cost is the same input equal to the same output, right? The more you hit something, the more the momentum will be, something like that, yeah? The action and reaction. That is the mathematical modeling. So they have sometimes the randomness element, but it is very minimal. Whereas for the statistical modeling, we need to include the random terms, right? And then we need to recognize relativity in the observation. So there are so many things that we need to look at, which are known as assumptions. We have so many assumptions. So the role of assumption, okay, in statistical modeling, compared to the mathematical modeling. So mathematical modeling based on the system mechanism, right? So the assumption based on the theory, done by the theory, but in statistical modeling, the assumptions more on the distributions, probability distributions, and then whether your variables are independent or non-independent, whether they are homogeneous variances or heterogeneous, something like that, and then whether you are using random sampling coefficient or something, right? So there are so many things that need to be considered. In mathematical modeling, sometimes we have a clear boundary, yes and no, A0, 0 and 1. But in statistical modeling, everything depends on the situation, the scenario, the subset factor, and then the target group. So there are so many things that we need to consider. So these are the examples that I will try to show how we can actually have, for example, gold prices forecasting. Oh, for your information, I belong to mathematics economics program in University of Malaysia Sabah. Even though we are under Faculty of Science and Technology, but our program is mathematics with economics. So in our program, we have three main clusters: mathematics, strategy, and economics. And then we try to combine them, all these three, and somehow we can contribute to the economics, especially in Malaysia, socio-economic, that's why we have educations and psychology inside the program, as well as we also have the public health, right? So because public health closely related to socio-economic as well. So these are the things, this is what is different between our program and your program. Yeah? In my university, we don't have mathematics education. So those who want to study for their postgraduate in mathematics education, they need to register under our faculty. So far I have one, PhD student doing mathematics education, how to assess the quality of teaching and learning by using fuzzy mathematics. Right. And then, so for example, the goal drivers forecasting. So we try to understand the economic mechanism, but in statistical modeling, we try to see the relationship or the association. So these are the examples. I just go further. And then about the population growth in mathematical modeling, we are more on the theory of the growth, right? And then in statistical modeling, we are looking at prediction under certain uncertainty, right? And then we have in engineering, okay, about the beam detection equations. Whereas for the statistical models, we have reliability reduction models. So these are two similar things, but under different models. Yeah, under different models. So we have also a model for agriculture. For example, crop growth simulations. This is more on the plant growth. And then for the statistical modeling, we have predictions for the yield. Okay, for the yield. So, so why do we need to do why the statistical modeling is important? Okay, why statistical modeling is important? In our life, everything is related, right? So in the family, we have husband, wife, and children, right? Everything got associated by other entities, by something, yeah, by something. And then the medium, so for the family, the medium is the family relationships. So that for us here, education, right? We have students, we have lecturers, right? And then we invited lecturers, guest lecturers, yeah. So we have the medium is the academy. So these are the things that you actually can relate on your daily life. The statistical modeling. We are looking at association. We are looking at the relationship. We are looking at the impact. We are looking at the impact. Okay? Now, so I try to actually map up, okay, map up the probability theory and the statistical assumption based on these four main things, which is relationship, and then where we try to see the patterns or trends, especially for me, okay, when we learn about the economics, we need to predict the trends, okay, the patterns, and then when we want to do the predictions, and then inferences. Most of my work is on inferences because I'm helping my colleagues from other programs, especially from aquaculture, scientific science, really to capture them. That is the reason why our program under Faculty of Science and Technology, not under the computer science. Yeah. Some of the university they put the mathematics program under Faculty of Computer Science unit, right? But not this one. Okay. So this is the most standard common model, statistical model, where we have everyone know that one is for the dependent variables, x1, x2 is the predictors, beta is the estimated parameters, and then we have the random error term. But I think because the first year, right, you already know the difference, the difference, the regression models based on the y. You already know, right? If your y is continuous, right, the x, the predictors is continuous, and we can go for simple linear regressions or multiple linear regressions. But when you change your y to ordinal, then you need to model it as ordinal regressions, right? If your y has is a categorical variables, and then you have only two levels, then you may end up with logistic regressions, right? And then if you have more than two nominal, two levels for the nominal variables, then you may end up with a multinomial regression. So there are dependence on the type of the variable. So the basic concept here is the type of variable. So how many types of the variable? So that's it. Depends on the level of measurement. Do you still remember? The first one, the lowest precision. I just mentioned this one, nominal, right? Okay. Higher precision is ordinal, and then we have interval and ratio, right? So this is sounds like very basic, but this is very important, yeah? Because from this basic, you will determine the type of the regression model, not the statistical model. This always happens to my students. I always emphasize on this because they always, take things for granted sometimes. Yeah? Right, the statistician superpower. This is a problem. When your kids, when you are working, right, I'm sure our statistic lecturer always, have these kind of problems. Your friends from other departments treat you as magicians, right? They have a data set, they give it to you, and then they hope that you will do a magic and produce the output for them. Am I right? Yeah. So I'm always saying my kids from other faculty, if you want me to analyze the data, you need to involve me from the initial stage, right? When you do your design of experiment, yeah, your research framework, I need to be there. I need to be there. Because the most important phase in statistical modeling is data collection. It doesn't matter how advanced your statistical analysis is, right? There will be a rubbish if the data is rubbish. Okay? So that's why we have the short terms GIDO. Okay, do not misunderstood, it is not gigolo. It's gigo, rubbish in, rubbish out. Right? The statistician needs to involve from the first stage. So in the era of AI, everyone uses AI, right? So you don't need lecturers. Just AI, you got the degree already. How's that? Right? How's that? Yeah? So sometimes, I'm not sure about students here in University Malang, the staff University Malang, but back in my university, it's quite challenging. Because of the AI, every time we in the class, sometimes the students try to catch the lecturers. Yeah, because they have the iPad, they have the smartphone, right? And then when I ask them the questions, then they got the answers already. Yeah. So what I did, I will ask them to explain. Okay. So when they need to explain, they need some sort of at least a bit of understanding. Even though with AI, we will understand, you cannot explain. Right? Yeah. So normally, if you have so many students, but it's very interesting. It's very interactive lecture actually. You need to be strong at heart. And then you need to be patient, right, doctor? Right. So, the advantage of you as mathematics and statistics is the understanding. That is the reason why you need to know the basics in order for you to have certain level of understanding. Everybody can perform the analysis, even those from other departments without strong mathematics background. But you will be different. You will be different compared to that because you know how to do it. At the same time, you have the understanding and then you know when the model breaks down, when the model has a breakthrough. Right? So you know how to interpret correctly. That is the difference between you guys and the students from your friends from the computer science or from the other IT faculty. Right? So your unique advantage as mathematics and statistics means you know why a model works, okay, and then you know how to predict when the model will fall or succeed, and then you can actually quantify how much you can pass the result. That is a certain statistic measurement for that, right? Right. So I give a critical thinking that software can make numbers, yeah, but statistician did the generating mechanism behind the numbers. For example, let's say if you have a correlation coefficient, right? 0.8. Okay? 0.8. Can you explain what 0.8 means? There are four keywords. The correlation test gives you correlation coefficient 0.8 with p-value equal to 0.01, and you are testing the test at alpha equal to factors. What do you say? What can you tell me on that? There are numbers, right? But there are lots of things that you can tell us. That is a strong positive linear correlation. Strong positive linear correlation. See, which words already right? Why do you say strong? Because the coefficient to it is closer to 1. Why do you say that it is significantly less? Because the p-value is less than 5%. Come on. Right? Okay? So, if you can explain that in full, so it means that you have a very good influence on the correlation itself. Yeah, correlation. Now, the next thing is Bradford illusion. This is something to do with machine learning. Machine learning is quite popular nowadays, right? So people are up to the point that machine learning approach actually manage to estimate parameters with lower error, okay, minimal error. But then statistical theory is important for you to actually develop the framework, the methodology framework before you can proceed with the analysis. Without the statistical thinking, you cannot actually proceed with a good analysis using the machine learning. So this is actually, I try to summarize it in this infographic. As you can see on that, this is you, right? So with all the blueprint and everything, right? But before you can actually model anything, there are a lot of things contribute to the models. The first one is the pure code, those who are doing coding. So if you are using R programming, so that's what coding, right? Involved. And then you have raw messy data. How do you want to screen the data? First of all, mine the data mining. After data mining, before the data mining, you need to screen the data, clean the data, right? So, and then you do the exploratory data analysis. Exploratory data analysis when you get to know the data, right? Before you talk to me, you need to know, before you, let's say, before you talk to someone, strangers, right? So before you ask someone, you need to know that someone. For example, you want to ask statistics, you cannot ask to tools from the physics department, right? So you need to know the person first. So that's the exploratory data analysis. And then what can you do with the noise? Then what can you do with the variance? How to minimize the variance and everything? So you need the data collection method, the best data collection method for the target group. So these are the I try to simplify statistical modeling in this program. I hope it managed to deliver the message. Right. The foundation in statistical modeling is the blueprint. What is the blueprint of the statistical modeling? Why you cannot build a good model, a breakthrough model, on a shaky statistical foundation? For example, a shaky statistical foundation when we are talking about means. Okay, so you have a data gender, and then your maybe your background, your when you join, when you register your PP, maybe you have different what do you call it? We have diploma, people with NCT, we have the pre-university level. How many admissions channels that we have in university as well? What makes them eligible to apply for the first degree as one? Secondary school only, not the pre-university level, not the pre-university level. Oh, you have an exam, but not a pass. Right. So in Malaysia, we have lots of channels. Pre-university programs, graduation programs, and then higher school programs, and then we have diploma. We have also Apple, APEL, based on your experience, based on your experience. So we have so that one, the category, and then let's say maybe your score in mathematics. The score in mathematics, right? So you want to find the mean. So you are using, let's say, The simplest one, what is the simplest one? Maybe Excel or the SPSS. Are you familiar with your SPSS? Right. So try to put the coding aside first, the art programming. So I always found that students sometimes they try to find in, for example, categorical variables. So it means this is what it means by the Shapley conditions. Not all the variables actually suitable for the analysis, especially in the descriptive analysis. So that's what it means by Shapley statistical condition. You don't know which variable is suitable for which test. So why statistical condition matters? Statistical modeling depends heavily on fundamental statistical concept because we have the risk that you might misuse the model. The second one, you might violate the assumptions, and then you maybe misinterpret the outputs. And then if you did all these three, then of course there will be unreliable predictions. So the effect is dikatakan diperlukan. Yeah? So a good statistician does not only know how to run a model, you need also understand why the model works, when the model fails and succeeds, and then whether the conclusion are statistically valid. Who do we know that our model is statistically valid? Agak-agak ni lah. Jadi, rasanya dia orang nak belajar kan regression model dah betul? So, macam mana tu? First year dia. So, factor apa yang dia dah belajar di statistik? So macam ni kalau pernah saya kan saya cakap and orang tak faham tu. Sebab tak faham tu cakap kan. So you haven't you haven't got the knowledge yet. Maybe this is the first time. I give you the overall the general idea, but please after this, please give me questions. So that I will know what you know. So this is the four statistical conditions. So definitely you know how to find the descriptive statistics, isn't it? This one daripada sekolah menengah lagi secara kan? Right, betul tak? Let's make it interactive. Descriptive analysis. You can actually categorize them into two or five. What can you say about descriptive analysis? Numerically and graphically, right? Let's say for the numerical analysis, right? There are three main numerical analysis. What are they? Okay, it's okay. Fine. There are three types of measurement under the numerical analysis. Descriptive numerical analysis. Measures of central location or central tendency, right? Measures of dispersion and measures of distributions. These are the three main ones, right? You need to know this because this is actually the foundations of the statistical modeling. Then we have probability theory. This is what my students hate so much, the probability theory. And then they will look at me with angry look and hate so much that even some of them say, "Doctor, I hate statistics." Okay, go down. I know you are surprised. And I will try to help. So, you can take statistics. Now, I understand that sometimes because probability is quite challenging. Yeah. So, and then sampling and data collection. So you need a data, right? Normally, for your first year, your lecturer will give you the data set. But when you do your final year project, I assume that during your final year project, you need to collect your own data. Yeah, when you need to collect your own data, that is the final data final. Yeah, and then if you are using data from any website, let's say for our country, for my student, most of them sometimes using the data from the Department of Statistics Malaysia, right? So that is a secondary data. Okay, data secondary, right? So you need to know how the right sampling method and data collection. Not all the data can be obtained by random sampling. Not all the data can be obtained by random sampling. But for first year undergraduate, normally we assume that our data is randomly sampled. Okay? And then we have assumptions. Different statistical method has different type of assumptions. So you need to know which one which, right? And then we have statistical inferences, and then you need to know what is the difference between correlations, relationship between variables. Sometimes we use correlation. What's the difference between these two? And then sometimes we need to measure the causation. So what is the difference between association, correlation, causation? So impact. Okay, right? Right. So, and then when you do your statistical modeling, the last one that you need to test is the model. So you will test by model evaluation. So there are so many model evaluations, but the main point in evaluating a model is by looking at the error. By looking at the error. Remember statistic apa? What is the difference between statistic and parameter? Okay, so we have sample and we have population, right? Okay, so let's see if our study based on University Malang students, and then I will take a sample for this group, let's say, maternity students. Maternity student will be the sample, right? The bigger group will be the population, alright? So in statistics, everything to do with data that we sample, right? So whatever the statistic values that we observe is actually estimation. Betul tak? When estimate means that there will be chances, the probability that your value is different from the true value, which is unknown. Nampak kan? Right? Very faham ke? Now, we need to see the love story about statistics. I love statistics very much. I tell you, I love statistics very much. I'm quite sad when my students say that they hate statistics. Right? Yeah. So everything is about the estimation. When you estimate, means that there is a probability that you won't get the same value, the true value. So we have the error term. So if the error is minimum or lower or smaller, then it tells you that the model is the best, right? The best, yeah. So we have also 8 selection criteria in statistical modeling that one we will either maybe final year or maybe doing ST or ST. Certain sometimes undergraduate will be able to find that's all right. Now, this is the descriptive statistic that I'm talking about just now. Central tendency measures, dispersion, and distribution shape. But I want you to read a very small sentence down there. It says, without descriptive analysis, modeling is a blind analysis. Right? So dalam terus pergi buat statistical test, you need to get to know your data first, do your descriptive analysis. The right one, you need to choose the right graph, the right table, and you need to be, it is an art actually in statistics, right? Bukan you just analyze and then copy paste the table and choose my report. No, you need to be creative. It is also an element of art. And then, why do we need to know all this? For example, we want to see whether there is outliers, and what should we do with the outliers? Should we include the outliers in, or we just omit the outliers from our data set? So it needs specifications. And then for the median, for example, it's quite obvious with the outliers, right? And the mode is very familiar and is very suitable for categorical data, especially when you are measuring about popularity. Okay. Now, for example, let's one example that, let's say, if you try to see, okay, what is the average of income in that area, right? And then you have one person with 100,000 income in a month, but the rest may be below 10,000. So it will distort the result. It will distort the result, right? So this is the probability theory, and it will go faster. Right, for example, you need to know normal, binomial, quotient, exponential. So when you learn about this probability distribution, you need to know what is the key concept, and then what is the type of data. The type of data, sorry, we haven't come to that one yet. And then this is the real world applications. For example, in normal, we have regression, residual, IQ scores, poison, when we are talking about the website traffic, harm data, for the exponential wait times, reliability, wait time, for example, if you call up the administration office, try a few times and then see in what time that they will call you see, or they will actually entertain you. Sometimes you give a call 10 times, they will even pick up. Right? So, or maybe the service in the bank, waiting time. Okay? Or maybe the traffic light. Okay, the traffic light. Or maybe you are looking at the anything that related to queue time. Okay? So this is also interesting. And then the most popular one is binomial. Binomial. This is very interesting binomial because from binomial you can get multinomial probability distribution. We got negative binomial probability distribution. We have hypergeometric probability distributions, right? Hypergeometric and then related to geometric probability distributions. Everything to do with the number of trials and the number of successes, right? So if you know how to define your X, and then you know whether the trials is open-ended or closed-ended numbers of trials, then you know which type of probability distribution that you need to use. So this is very interesting and challenging, right? Right, so this is the 8 dimension of data quality. I will skip that one, but if you want to have the top of your mind presentation, I will share. Yeah. Yeah. Right. So this is about the statistical inference, right? The p-value, the hypothesis testing, the confidence interval, right? These are the main things that when you do the hypothesis testing. Because hypothesis testing, any statistical modeling, they have hypothesis testing, right? I'm not sure whether you have this or not. I'm confident that you do, right? No, okay. Whenever you want to test something, right? Test something. Let's say you have mathematics score. Yeah, you have mathematics score. You are the new judge. And then let's say Dr. Jamalato want to compare your performance with the previous judge, for example. And then she just wants to know whether is there similar or not. Then she doesn't really care whether you have the highest score or the lowest score. Then she will proceed with the true hypothesis. But if she wish to know that you are better or not from the previous group, then she will go for one case hypothesis testing. Right? One case hypothesis testing. If you are better, okay. So if you are better means that right tail hypothesis testing. If she wants to know that maybe you are actually poorer compared to the last section, she will proceed with the left tail hypothesis. So this is the thing, right? When you do your statistical modeling or your analysis, you need to know what is your focus, what is your aim. Then you decide what type of hypothesis testing. So when you learn the topic, then you will get the full picture on that. And when you do your statistical modeling, remember just now when we have 1 equal to beta naught plus beta of x1 plus beta z2 and x1. Remember? The equation just now, this one, yeah, this equation, right? So you need to estimate the beta naught, beta 1 and beta 2, right? Right? So whether x1 or x2 is the significant predictor to y, right? So you need to test the coefficient, the beta 1 and beta 2. So how do we know that it is significant? Based on the statistical evidence. So which is the statistical evidence? Where we can actually measure the statistical evidence, which is the p-value. P-value is the statistical evidence, right? So let's say if you test your hypothesis testing with alpha equal to 5%. Alpha it is a concept that because this is statistics, you are estimating everything, right? So you won't get a value that is 100% similar to the parameter, to the true value, right? So in hypothesis testing, let's say when I say that alpha equals to 1%, that is the probability of you actually committing the type 1 error. Type 1 error is when you rejecting a true null hypothesis. So this is the maximum allowance for you to do the error, right? So we we put some sort of uncertainty there, right? Uncertainty. So actually, doctor, my student also came about this. Yeah, I keep on, give the lotion from the distribution, this is the thing you can do, and then you always got confused with the alpha. You always got confused with the alpha. This is actually the things that the statistical software developed based on the p-value, right? I hope you will understand this later on. And I think your lecture will have very big time at time. Yeah. Right, so this is the example for correlation and causation. So, correlation from the word correlate, causation from the word cause. This is the good things about the term in English. Okay, for example, nominal just now, it came from the word name, naming, there is no ranking, right? Gender, it is a nominal measurement, right? There is no ranking, tak ada kata lelaki lebih tinggi daripada perempuan, perempuan lebih tak ada, there is no such things. It's similar to colors, it's different, that's all. Ordinal came from the word order, means something that you can rank them, right? So it's very interesting. So, same goes with correlation and causation. Yeah, correlate does not necessarily causation, right? For example, here when we have, let's say, we have three types of data: temperature, and then the sales, ice cream sales, and then the drawing example, the drawing cases. Let's say that day the temperature is higher, the sales of ice cream increase, and the number of people drawn at a nearby beach also increase. Right? Does it mean that the higher temperature, the more people will drawn? Nothing must. Yeah? Is it correlate or causation? Let's say the temperature is higher, the number of ice cream also higher. It is might be most probably causation. Yeah? When the temperature is higher, then you feel thirsty and you feel that you want to eat ice cream. Right. But it doesn't mean that if you more people eat ice cream, buy ice cream, then there will be more people run until mass. It's correlate but not causation. Can you see the difference? Huh? Correlation and causation. So people in IT they can run the analysis, but they don't know the background. But you, as a statistician and mathematician, you can actually know, understand the background of the problem, the scenario of the problem, whether it is actually makes sense or not. Right? That is okay, this is about the foundations of mathematical communication. I will go faster. This is the type of the diagnostic test. For certain assumptions, there are four pillars or four important assumptions, which is normality assumption, independence assumptions, homoscedasticity, and non-multicollinearity. If I explain it one by one, I think you will get more. This is the main four pillars of statistical modeling. You must test whether your data is normally distributed, and then you need to make sure that the something is the data is independent from each other. Okay, and then you must make sure that when you compare two groups, for example, the variance are equal or more or less similar. But this is what we call the homoscedasticity. For example, how many minutes after? Just remind me. Then I will stop wherever I can stop wherever. Okay. So, then stop. Okay. Okay, I'll give you the final explanation. When you want to compare two groups or more than two groups, you must make sure that you compare the right group. That is what you mean by homoscedasticity. If I want to compare, let's say, performance between two groups, and then this group mathematics performance, right? It is very biased if I compare the mathematics performance between the mathematics student and non-mathematics student for the same test. Right? So they might give you different variability because they have different background. It is very unfair. It means that you cannot compare apple to apple or something like that. One, right? So I think I will end my lecture. Thank you so much. I'm sorry I took too much time.
No, thank you, Dr. Baby Shoman. This was a great opportunity for us. Because the time is over, and I think we don't have a question session. Okay. We have one question for audience. You can raise your hand. You can, Doctor, if our audience ask in Indonesian. Oh, okay, it's okay. So you can, so you can ask our doctor in Indonesian language. Okay, ada? Ah, we have class of today. The silly question is the best question. Okay, everyone? Everyone? All the material is clearly clear? Oh yeah, Jamal.
Do you know what critical thinking is? Do you know what critical thinking is? It's okay if you want to use that ChatGPT in mind. It's good actually because that's what it has and that's what actually needs. It's a need actually nowadays. But we need to use it wisely and intellectually. Yeah, wisely and intellectually, right? So when let's say when you read the answer that you obtain from ChatGPT, for example, right? Make sure you read line by line. If you don't understand the line, maybe they using big words, like big jargon, right? After, after ChatGPT, what do you mean by this sentence? And then they will keep on explaining to you, and without you knowing, you are actually learning. You are actually learning, you know. Maybe maybe you can say that, one thing in using AI is you need to give ChatGPT a good and the correct prompt. You know what correct prompt means? Let's say you need ChatGPT, the AI to think like you are first year undergraduate student. Yeah, you are the about this, but you don't understand this. Yeah, and then you need to complete this assignment, this lecture, blah, blah, blah. How should you do it? Simplest way, right? Without using any big words. So they will actually do it for you. But this is not actually easy. You're actually doing it intellectually. Yeah. Even though if you are, let's say, doing the assignment, nowadays, people the ChatGPT can do 100% and they can actually do the analysis for you. But you should know what the ChatGPT is. Right? It's okay if you don't know at first. Keep on asking them. You are the lecturer. You ask them to do the lecture, the student yourself, but you are the lecturer who actually investigating, asking the chat you. Alright. Can you understand that? Yeah. So when you do that, actually you are learning. That's the process. Right? So if you ever do that, right, you will find that learning is something that you learn. It is something that very satisfying. Definitely good. Fun. Sorry. At least one question. Cuba tanya soalan. Cuba tanya soalan. Kita bahas saya, mereka tak faham sekarang. Any questions, please? At least one. Thank you.
Silakan disebutkan namanya.
My name is Chakravarti Mahaprabhula. Saya dari Universitas Negeri Malang, saya masih belum lulus sastra.
Baru baru muda kita berdua. Ini positif. Do not use negative word.
Di sini saya mau tanya, gimana cara efektif kan Ibu bilang mau efektif sampean kan susah kesusahan dalam itu ketika PKI susah dalam online. Kan tadi dosen kamu bilang kalau anak didiknya kan kesusahan ketika alfa, nah itu bagaimana ketika lebih gampang.
This is actually the same question given me by the English student. Last month, I spent 1 week at the university because I was invited lecturer. And then the key value is actually the most common problem faced by the mathematics student. So if you want to understand the p-value, the first thing that you need to understand is the table of inequality. But I skip that because we want to make it faster, right? So the main thing that you know is you need to know is alpha. Alpha is the probability of committing type 1 error. Okay? Type 1 error. Probability of committing type 1 error. So you need to know what is type 1 error. Type 1 error means that you reject null hypothesis given that the null hypothesis is true. The probability of rejecting null hypothesis when the null hypothesis is true. As I make it standardized. You understand that? Kalau saya cepat, saya tahu. Kalau memang saya banyak informasi cepat. Mathematics and statistics, that's always like that. In our mind, it's going very fast, right? So when it's going faster than our mind, it's very difficult to our students as well. Okay? So alpha is the probability of type 1 error. So type 1 error is the probability of rejecting null hypothesis given that the null hypothesis is true. Do you understand this concept? Yeah? So it means that alpha is probability value, right? So probability that value is between 0 and 1. No? Right. So the easiest way is to connect this idea into Gaussian probability distribution. What is the elements of the Gaussian probability distribution? It is symmetrical, right? And it looks like a bell shape. Am I right? Okay. So, right. So let's see if I want to do two theory possibilities. If we have two theory possibilities, then we have two rejection regions. Am I right? Okay. So we have this one and then this one. So this is the irony, you know. This is called rejection region. Okay. And this is also rejection region. and this is the acceptance region. Okay? Let's say if I set my hypothesis at alpha equal to 5%, then we know this critical value is negative 1.96 and plus 1.96 because this is that 0.025 and this is also that 0.05. Do you know how to find this from your probability table? Number table, you know, right? Okay. So now we are talking alpha. Alpha is actually the total area under the reflection. This is the problem when we are using statistical software. Because some of the statistical software rely the alpha is actually for the one case. Some of the statistical software, the alpha is actually related to two here, two rejection region. So you need to know what is the software used. Okay. So let's say alpha is 5%, meaning that the 5% is the combination of the left and the right. Am I right? The left and the right. So the thing is in p-value, okay? Let's say the p-value is 0.025. Let's say 0.025. Okay? So the p-value, let's say for example, FSF is the combination of the both sides. Both sides. So if you look at this one, this one is 0.025, this one also 0.025, isn't it? Right? Okay. So let's say if we are talking about this is 0.025, but the p-value is 0.025. So we are talking about two scales here. Do we need to define or do we need to translate? P-value is the total rejection region. It means that it will be smaller than this one, right? Look at that. So the p-value will be somewhere here. Let's say you run here. Okay, so it is within the rejection region, right? Within the rejection region. Okay, try it. Let's say we use one filter. One filter. Okay, maybe this is more simple. This is 0.05 because alpha is 0.05 and now, right? Okay, so now let's say your p-value is 0.025. Okay, so p-value will be somewhere here. Okay, so why do we need to reject our null hypothesis if the p-value is within this rejection region? Because just now the alpha said the possibility that you are committing that whatever is 5%, right? That is the maximum allowance, right? Now, p-value says if you reject the null hypothesis, the error will be 0.025. The probability of committing that one error is 0.025. Is it lower or higher? Lower, right? Pick up the null hypothesis. Pick up the null hypothesis. Means that you can reject the null hypothesis because the probability of committing that one error is lower than 5%. Does it make sense? Yeah, it means that yes, you can reject because the possibility that you can committing that error is very low. It's very low. But if your p-value is, let's say 0.20, right? Your rejection region is 0.05, right? 5%, right? But you can reject. Definitely you cannot reject the hypothesis because the probability of you committing the type 1 error is very, very high. You cannot reject the null hypothesis. It is very simple. It's just playing with the rejection region. It's just playing with the rejection region. And then it is very nice exercise. You tengah minum kopi kan kita update the other way. I had my coffee lagi. It's nice. When we went into the cafe, and then I told my dean, Prof, all of them are Gen Z. We are the only bapa-bapa here. And then Prof Reno said, okay. And then we bought rumah, what? And then, okay, go to the IT room. So almost go to the IT room because we are the only four.
Senior.
Look for 31.
Mature.
Okay, this is the way. And then one more thing. if you reject your non-positive one, it's your decision group. If you can reject your non-positive, let's say your p value is less than the alpha. Okay, I repeat. If let's say your p value is 0.20 and then your alpha is 5%, you cannot reject the non-positive, right? So what is your conclusion? No, just bagi total. Jangan lupa. 20% p value, maknanya kebarangannya untuk kita mengenal hipotesis nol atau null, ya, adalah tinggi, right? Jadi apa conclusion dia? Okay, agree, accept what? The null hypothesis. Accept the null hypothesis. The p value. Kalau kita p value kita letak daripada kita punya alpha, barangkali yang dibenarkan untuk commit the type of error, apa conclusion dia? Cuba, tak ada okay. Tak ada masalah kalau salah. Salah pun belajar. Another way to learn. Beritahu saja nanti salah-salah. Right. She said we accept the test. No, I understand why she said we accept the test. Not because it is the subcondition right. But in the concept of hypothesis, we cannot accept that. Now hypothesis. What we can say is we do not reject the null hypothesis. Do you understand? The reason why is because the data null hypothesis is something that you accept is true or based on the historical data. You believe, but you didn't test it. You just believe, but you didn't test it. So when you collect the data is to be used to test whether you can still believe the same value. Can you still believe or accept the same value? That's it, right? Right. So, but we didn't test the null hypothesis, we just believe, right? So you cannot say that, oh, you accept the null hypothesis because it is not for the null hypothesis, the data is for the alternative hypothesis. That is the ironic thing that the hypothesis is that this is actually a common mistake. So train yourself. Do not say accept null hypothesis. The decision rule is either you reject the null hypothesis or do not reject the null hypothesis because you haven't got sufficient evidence to reject it yet. Maybe next time when you collect the data, your sample size is bigger, you have sufficient evidence, then you can reject the null hypothesis. Is it clear? But sometimes I don't expect you to 100% understand, but as long as you are, and then you will come back to you later on. Inshallah. Boleh kan?
Oke, karena kita sudah di ujung acara, we can take a picture together for everyone coming forward. Doctor, can you take a picture together? Okay.
Saya dari sini. Oh, cukup nggak wifi? Nanti ini juga ini pencet aja langsung. Misalnya ke kunci. Oh iya. Pakai ini boleh. Oh iya. Siap.
Kelihatan nggak kalau naik ke atas? Bisa mengatakan.
Apa juga blocking nanti logonya. Yang cowok belakang, yang perempuan dari tengah. Iya.
Silakan yang merasa
Merasa tinggi.
laki-laki, laki-laki dulu dong Pak. Yang merasa laki-laki di belakang tadi. Terus yang perempuan boleh di tengah. Silakan. Nanti dokter di tengah. Dokter. Ya, silakan.
Oh, jadi duduk saya. Gimana Pak?
Nunggu ya, Pak. Oh, bisa Pak.
Bisa ya?
Ya, lagi. Ya.
Pak. Kalau ada yang duduk, dokter, silakan. Jamal, dokter.
Ya, enggak terlalu jauh, Pak ya.
Dek, boleh Dek. Natasha, depan. Natasha depan. Oke, sudah kelihatan.
Separuh ke sini.
Oh, ya,
Ke sini ya.
silakan. Boleh ke sebelah kanannya dokter. Ini. Oke. Ini kamu.
Cowok dua pindah sebelahnya Pak Imam. Nah. Oke.
Formal pose. Formal pose. 1, 2,
Oke.
3.
Three. Habis. Ikut Pak. Go, Pak. Satu lagi ya. 1, 2, 3. Oke. Lagi. 1, 2, 3. Oke. Oke. 1, 2, 3. Sip. Oke.
Oke, sekian ikut acara Deselektor hari ini. Apabila ada salah kata dan perbuatan dari saya selaku MC dan moderator, sekali lagi berikan tepuk tangan kepada Dr. Siti. Thank you so much. Oke, assalamualaikum warahmatullahi wabarakatuh.